Alright guys, this is our second part of the video. We have the dimensions of a rectangular room, and we're finding the area and the perimeter. So if this is my picture of my rectangle, I have 3x minus 4, and then I have 3x plus 1. Now those are going to be doubled up on each side, so this is also going to be 3x minus 4. So perimeter is all about just going ahead and adding all sides. So we're just going to add all sides. Okay, so I'm actually going to do that first. So I'm going to do this kind of quick. 3x, 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 3x. So I have 4 times 3x basically, which is going to give me 12x. Combining like terms, right? Negative 4 plus a negative 4 is a negative 8, plus 1, that's going to give me a negative 6. Okay, so I'm just going to get a total of negative 6. So here's my answer for my perimeter. Kind of fast. Area is going to be length times width, so we're going to multiply these two pieces together. And to do that, I'm going to use our favorite thing, the box method. Okay, we've already had a lot of practice on this on the first part. 3 times 3 is 9. That's going to become x squared. That's going to be negative 12x, 3x, and negative 4. Like terms are usually down that diagonal, so we get 9x squared. This is going to become a negative 9x minus 4. And there you go. Area, you multiply length times width. Perimeter, you add all 4 sides. Don't forget that. Number 18 through 20 are exponential rules. Review. Alright, so we have s8 and then t to the 4th, and that's getting multiplied by negative 6s over t to the 5th. Okay? Well, essentially what's going to happen here is I'm going to basically put this over 1, and I'm going to multiply straight across. This is going to become negative 6, goes in front. S times s to the 8th, they're going to add to make s to the 9th. Then I'm going to get t to the 4th, and on the bottom I'm going to get t to the 5th. I got to simplify this. Notice that there's a t on the top and the bottom. So we got to do some subtraction, 4 and 5. So our exponential rules say when dividing, I subtract exponents. When multiplying, I add exponents. That's why I had s1 times s8 made s9. So this is multiplication, product rule, and division, or the quotient rule, right here. 5 minus 4 is 1. Where do I leave the 1? Well, I leave it where the bigger number is to begin with. T is bigger on the bottom with 5, so I'm going to leave t to the 1st on the bottom. And there's my simplified answer for 18. Number 19, drastically easier problem, but what we're doing is we're just multiplying. And the product rule states when multiplying, add. 4 plus 3 is 7, plus 1 is 8. Number 20, another easier problem. We have negative 4 squared. Okay, negative 4 squared to the negative 2 power. To handle this, to get rid of that negative exponent, we have to put it all under 1. Next, I got to square 4. That's 4 times 4, which is going to give me negative 16. Notice the 4 is getting squared and the negatives on the outside. If the parentheses include the negative, I'd have a positive 16, but it doesn't include, so I have a negative 16. And 21, last but not least, this is simplifying a radical. What two numbers multiply? If you can't think of any good ones, and if it's even, do 2. That's going to be 2 times 54. Now, I recall 54 is a pretty easy one for me to remember. It's 6 times 9. Also, I remember that 6 is 2 times 3, and this is 3 times 3. Now I'm going to pull out doubles. When I square root, I can pull out doubles. So the doubles I can pull out are, I see 2 2's. So I can pull that out. I see 2 3's. Multiply, I can pull that out. What I'm left with is a 3 behind. So that has to stay inside. He doesn't get to escape. Multiply the 2 and 3 together, and I get 6 rad 3. Pretty simple. Alright. Number 22, 23, 24, and 25 are going to require a calculator. Now we did 22 in class, so we're going to skip that one and go straight to 23. Now, the first thing I got to figure out if it's growth or decay. population of flies have gotten sick. Their population is 20,000 and is shrinking. Shrinking rethinks that this is probably decay. So I'm going to go ahead and write my decay formula. I'm just kidding. That was the growth formula. There's the decay formula. My population is 20,000. Remember, population is our A. Times 1 minus the rate. It's doing it by 5%, which we turn into a decimal of 0.05. Move the decimal over twice. And we want to know what will be the population after 6 days. Okay? Well, from here I'm going to bust out my calculator, and I get 20,000 times 1 minus 0.05. And if you do that, you get, probably could have done that one in your head, 0.95 raised to the 6th power. Now that part you probably can't do in your head, but 0.95 raised to the 6th power is approximately 0.735 yada yada yada. I'm going to leave it in my calculator and multiply it by 20,000. Okay, when I multiply it by 20,000, I should come up with about 14,701.83 flies. We'll round up, and we'll just say there's another fly, and there it is, our answer. Those are the amount of flies that we have remaining. Now I want you to have your final answer and our calculator ready answer. So there's our calculator ready answer, and there's our actual answer with our calculator. Alright, now we're going to solve this one. Here we go. The amount of minions is 400 and is increasing at a rate of 10% annually. Increasing means I'm going to use, for 24, y equals a 1 plus r times t, or raised to the t power. So we have 400, that's the amount, that's a, amount or population, 1 plus the rate, which is 10%, move it over twice, that's 0.10, over 2 years. This is going to be 1.10 raised to the 2nd power times 400. Now here's my calculator ready form. Now I'm going to do 1.1 raised to the 2nd power. And when I do that, I get 1.21 times 400. And I'm going to come up with 484. And those are my minions. And our last one, 25. Okay, there are 10,000 stormtroopers, but the resurgence of the Jedi, they are slowly decreasing at 25% a year. How many stormtroopers will there be after 3 years? Okay, this is exponential decay, so I'm going to subtract. I start with 10,000 as my population. 1 minus 0.25 raised to the 3rd power. That's going to become 0.75. I can do that one in my head. I'm good with quarters. And 0.75 raised to the 3rd power is going to be kind of a long number, 0.421875 times 10,000. Again, this is where a calculator is so very nice. And so we end up with about 4,218.75 soldiers. So we should round that to probably 4,229 stormtroopers. I'll call them ST, stormtroopers. Alright guys, good luck on the test. Thank you very much. Goodbye.